In this question, it is given that if a particle of mass m is moving with a constant velocity v parallel to x-axis in xy plane as shown in figure, its angular momentum with respect to origin at any time t will be. So over here, actually they are not mentioned the diagram. So let's see what about the diagram over here. So according to this question, we are just considering an xy coordinate system, something like this. Okay. So in this xy coordinate system, here consider that a particle is moving along this direction, which is not mentioned in the question. Actually, they should give this one. So this diagram, then only we'll be able to find out it. So consider the diagram is something like this: a particle of mass m, which is moving with the velocity v along the parallel to x-axis. So let's say along parallel to x-axis, it is moving with the velocity v. And our aim is to find out what about the value of angular momentum with respect to origin. So actually, you learn this calculation of angular momentum in like rotational motion. Now you can just consider that it is, we are going to find out it's something like this. Assume that its position vector is represented by r vector, and the angle between this position vector and this velocity vector is nothing but theta. So the definition for angular momentum is equal to moment of linear momentum, or we'll find out it by using this equation r vector cross p vector. Now let's see what about the magnitude of this angular momentum, that is magnitude of r cross p, that we can take it as r into p into sine theta. Over here p is nothing but momentum or linear momentum, that is mass into velocity. So mvr sine theta is the equation for magnitude of angular momentum of a particle which is moving in a straight line. Now we can observe that in options it is given in terms of b. So what is b over here? So actually that they should mention in this question what is b. So actually b is nothing but this distance. Okay. So we can say that if this angle is theta, this angle is theta. So this component is going to be, means I'm talking about this component. This is r cos theta and this component is r sin theta. So the value of b is equal to nothing but r sin theta. So if I'm modifying this equation, that is m into v into sin theta into r, can be written as m into this v into r sin theta, m into v into r sin theta. I'm just writing in this form because we just now come to know that this r sin theta is nothing but b. So you can write m into v into b is the equation for its magnitude of angular momentum. Now along with this, we need to find out the direction also. For direction, we can find out from the direction of r vector cross p vector by using right hand thumb rule. If you are going for r vector cross p vector or r vector cross v vector, this is r vector and this is r v vector. So if you are going for r vector cross v vector, that according to right hand thumb rule, thumb will be in downward direction, means perpendicular to this plane and downward, that is negative z axis. So we can write this as minus k cap.